Hello everyone. We have a question which says that a particle Q over here of mass 0.2 kg, and definitely the particle Q mass is 0.2 kg, is held in equilibrium. So the condition is an equilibrium condition, and it is held by two light inextensible string, and this particle Q is held by two string. This is a string and that is the string. So string PQ, which is this one, the string PQ, and QR, and definitely this QR. P is a fixed point. Yes, we can see it is a fixed point on the vertical wall. Yes, and R is a fixed point on the horizontal floor. We can see over here very clear. The angles which string makes, the angles which strings PQ and QR makes with a horizontal are 60 degree and 30 degree, very clearly mentioned over here that the angles which strings PQ, this PQ, and QR makes with the horizontal. So this is a horizontal, the dotted line, they are 60 degree and 30 degree respectively. Very clear. Find the tension in the string. So basically we have to find the tension in this string and we have to find the tension in this string. So the tension in this string would be the tension in PQ, the tension in this string would be the tension in QR. So basically we have to find the tension in PQ and the tension in QR. Because the condition that they have given to us is an equilibrium condition, so we have to split them up into components, because equilibrium means the opposite forces are equal, and definitely when we say the opposite forces are equal, that means the opposite horizontal and vertical forces are equal. For that we have to split them up into horizontal and vertical component. But before that we have to understand what the components are. Mostly I have seen that students have a misconception that the horizontal component is always a cos component. No, it is not like that. If this is an angle theta, then the side next to that would be a cos component of that particular force, and the opposite would be a sine component of that particular force. But if the angle that is given to us is over here with the vertical, I mean with the y-axis, we can say that the side next to that angle would be a cos component of that particular force, and the opposite would be sine component of that particular force. That means it depends upon the angle where the angle is, and based on that angle we will decide which side would be a cos component side and sine component. If we look at the diagram very clearly and split them up into component as I have done over here, the tension in PQ is making a 60 degree, so definitely this 60 degree is with the horizontal. So the side next to 60 degree would be the cos component of that tension in PQ. So I have written over here TPQ cos 60 degree, and definitely the opposite would be TPQ sin 60 degree, which is the vertical force. Similarly, for this 30 degree and the tension in QR, this 30 degree is with the horizontal, so that would be a cos component, so that would be T QR cos 30, and vertical component would be T QR sin 30 pointing downward. And similarly, the weight of the mass of the particle Q, which was written over here as 0.2 kg, multiply that by 10, because weight is equals to mg, m is 0.2, g is 10, multiplies both of them, and we have 2 Newton, which is the weight of particle Q. Because question is that the condition is an equilibrium, so definitely now we have to work based on horizontal component and vertical component. If you just look at the horizontal component, we can see over here, and look at the diagram, we can see over here we have two forces. One force is to the left of Q, which is TQR cos 30, and one is to the right of Q, which is TPQ cos 60, because the condition in it is equilibrium condition. That means TQR cos 30 degree would be equal to TPQ cos 60 as I have mentioned over here the same. So TQR would be equal to TPQ cos 60 divided by cos 30 and get the value of cos 60 divided by cos 30, which is 0.577. Now we have a condition in terms of tension in QR and tension in PQ, which is equation 1. And definitely in the question they asked us to find the tensions in the two string, and basically we have to find the value of these two, the tension in QR and the tension in PQ. This equation was based on horizontal forces. We will create one more equation based on vertical forces. Now look at the diagram. Over here, we have a vertical force pointing upward, the tension in PQ sine 60. I have written over here TPQ sine 60, and we have two vertical forces pointing downward, which is the tension in QR sine 30 degree and the weight of the particle. Both are pointing downward due to the equilibrium condition. Definitely this TPQ sine 60 would be equal to the sum of these two. That means TQR sine 30 plus 2. Now placing the value of this TQR over here, placing the value of this TQR in the equation, and before that just get the value of sine 60, which is 0.866 TPQ, sine 30, which is 0.5 TQR plus 2, which is the equation 2. Place this value of TQR over here, which is 0.577 TPQ, and multiply that by 0.5 as I have written over here, and the same 0.866 TPQ equal and plus 2 like over here. Now over here you can see the complete equation is in terms of TPQ, the tension in PQ. Just solve it, simplify it, get the value of TPQ, which is 3.46 Newton. Now just use the equation 1, which is TQR is equal to 0.577 TPQ. Place this value of TPQ over here, which is 3.46, multiply that by 0.577, and finally the tension in the QR is also found. So finally we have found the tension in PQ and the tension in QR, which was the requirement of the question.